Hey guys, Math Lamari here, and in today's video, we're going to cover a very interesting equation that has a pretty unique and a fun solution. It says the following: let x and y be positive integers. Find the solution to the equation x to the sixth power is equal to y to the second power plus 127. Now, the fact that x and y are positive integers is very important, which you'll see as we continue further in the problem. But first, we have to figure out how exactly we're going to approach this. And what I start by doing is just try to maybe rewrite this equation in a way that would be easier to solve. Start by just subtracting y squared from both sides, because when we do this, now we have all of the terms that have variables on one side, and then we have a constant on the other side. So when you subtract y squared from both sides, you end up with x to the sixth power minus y squared is equal to 127. There are a couple of things that I want you to pay attention to here. One is that we have a difference, subtraction, right? And the other thing I want you to notice is that we have two exponents here that are even numbers. These two facts are going to help us to further rewrite the left-hand side of this equation so we can make more progress in solving this problem. And since we have a difference, what I'm thinking we could use is the difference of squares formula. I'm going to right here use difference of squares formula. And in case you don't remember, the difference of squares formula says that a squared minus b squared is equal to a minus b, the quantity a minus b, times the quantity a plus b. Now, hold on, I know what you're thinking. You're probably saying to yourself, hey, this doesn't look right. You know, we have this y squared here, but we also have this x to the sixth power. But this difference of squares formula doesn't have an exponent of 6. What the heck are we going to do? Well, we're going to rewrite this x to the sixth power as a square, because we know that x to the sixth power is equal to x to the third power squared. You have x to the third power, and then this is to the second power, and this is equivalent to x to the sixth power, which means that x to the sixth minus y squared is equal to x to the third power squared minus y squared. So now that we've rewritten our left side of our equation as a difference of squares, we can apply the difference of squares formula in order to make some more progress here. Now I'm going to say that we can let a equal x cubed and b equal y. If we make this substitution, we get x cubed minus y times x cubed plus y is equal to 127. All right. Now, at first it might look like we made things even more complicated, but this is where the fact that x and y are positive integers comes into play and becomes very important. We're also going to use the fact that 127 is a prime number. What's a prime number? Well, a number that's only divisible by itself in 1. I'm going to write here, I'll write down here actually, that 127, I'll say the only factors of 127 are 1 1 and 127. This is important to keep in mind. But also, since x and y are integers, that means that either x cubed minus y is equal to 1 or 127, or x cubed plus y is equal to 1 or 127. If x and y weren't positive integers, then this equation as written would be pretty tricky to solve, because these two numbers here, these two variables, could have been equal to any decimal or irrational number. But since we have positive integers, that makes things a lot easier on our end. All right, so now you might be thinking, well, how do we know whether or not x cubed minus y is equal to 1 or x cubed minus y is equal to 127, and then the same for x cubed plus y? All right, if we think about this, we can see that x cubed plus y is going to be equal to 127, and that x cubed minus y is going to be equal to 1. The reason we know this is because x cubed plus y cannot be equal to 1. And again, that's because x and y are positive integers. Since they're positive integers, that means that both x and y are at least 1. So the smallest possible value of this expression, x cubed plus y, will be 1 cubed, which is 1, plus 1, which is 2. Because of that, x cubed plus y is not equal to 1. X cubed plus y would have to be equal to 127, which means that x cubed minus y would have to be equal to 1. I know that was a lot of information to take in, so if you need to rewatch that part of the video to understand the reasoning here, feel free to do so, of course. I'm going to write here, since x and y are positive integers, and 127 is a prime number. I'll say because of these two facts, these equations hold. Now we have two equations and two unknowns. From here, there are a couple of ways that we can proceed, but just based on the way these two equations are written, the easiest method would just be to use the elimination method for solving systems of equations. For the first equation, I'll write 1 here and 2 here. We have x cubed plus y, but for equation 2, we have x cubed minus y. So if we add these two equations together, the y is going to cancel, and then we end up with an equation that just has one variable, which is a lot easier for us to solve, right? I'm going to write here that 1 plus 2 gives us 2x cubed is equal to 128. As we discussed, the y's cancel on the left side. X cubed plus x cubed is 2x cubed. And on the right side, 127 plus 1 is 128. Now from here, we're going to just solve for x. We're going to divide both sides by 2 to get x cubed is equal to 64. And then take the cube root of both sides to get that x is equal to 4. And then from here, we still need to find y. So what we can do is just substitute this value of x we found into either equation 1 or 2. Now it doesn't matter which equation we use. Personally, I'm just going to use equation 2 just because it'll be easier to make the substitution there, since on the right side we have a way smaller number. We just have 1. But again, mathematically speaking, it doesn't matter which equation we choose. So I'm going to write substitute x is equal to 4 in equation 2. Now if we do that, we get x cubed is going to be 4 cubed, which is 64, minus y is equal to 1. Now, if we subtract 64 from both sides, we get negative y is equal to negative 63. And then from here, if we either divide or multiply both sides by negative 1, it doesn't matter. Then the negatives cancel and we get y is equal to 63. And from here we have our solution pair. Solution is x is equal to 4 and y is equal to 63. And this is the problem. Like I said, I do personally think that this is a pretty fun problem. It doesn't really require advanced algebra knowledge or anything that's too obscure. You just have to know how to apply a difference of squares formula properly. And the fact that we also had positive integers for x and y make this problem pretty interesting to solve as well. Anyway, if you have any comments, suggestions, feedback, or any questions you want to ask me, please let me know in the comment section. I will answer any sort of feedback you have for me. If you have another solution you thought of, definitely let me know in the comment section. I'd love to hear that as well. Otherwise, I hope you enjoy the rest of your day, and I will see you in the next video. Bye now.